All right, kiddos. Hope everyone's doing well. May 5th. Giddy up. Weather's nice. Spring term. Today what we're going to do is we're going to look at how to find area of regular polygons with n sides. So remember, regular polygons have congruent sides and congruent angles. So we're looking at really nicely behaved polygons. So all the sides are the same, and remember all these angles are also the same. So everything nice happens. So what we're going to do is to find these areas, we're just going to use triangles. Right, so we're going to split it up into a number of congruent triangles, find the area of one triangle, and then multiply by the number of triangles we have. So let's take a look at this example. I think it's probably easiest to look at an example. Here's a regular hexagon, and let's suppose that the sides of the hexagon are all 12. Right, so all these sides are 12. It's regular, so they're all the same. Right, so what I really want to do is I want to find the area of. If I split this up, I can cut it up into 1, 2, 3, 4, 5, and 6 coming up. So essentially I find the center of that regular hexagon, which is ironically the center of a circle that could be about this regular hexagon, if you think of the hexagon as being inscribed. So I find the center, and then I create all these congruent radii. And what I'm also doing is I'm creating 6 congruent triangles. 1, 2, 3, 4, 5, 6. Now they're all the same, so what I'm going to do is I'm going to find the area of one of those and multiply by 6 to get the area of the whole hexagon. Right? So any one of these triangles has a base of 12, right? 12, 12, 12, etc., etc., 12, 12, and 12. It's regular, they're all the same. What I need, though, is I need some angles, right? And so the neat thing is that all of these central angles, right, if you think of a circle about this regular hexagon, all of these 1, 2, 3, 4, 5, 6 central angles are all congruent. And since they all add up to be 360, each of those central angles is 360 divided by 6, the number of triangles or sides. And, of course, that gives me 60 degrees. Oops. Right, so each of these central angles are all the same. They're all 60 degrees. Right? Which is great, because now that's 60, that's 60, that's 60, that's 60, that's 60, and that's 60. All these 6 triangles are the same. Right? So what I'm going to do is I'm going to take that any one of those triangles, and I'm going to find the area of one and then multiply by 6. Right? So the next thing I want to do is I could, I guess, find these angles to one of those 6 triangles. And so since those are both radii of the same circle about this hexagon, those are both congruent. And basically by ITT, these 2 base angles of that one triangle have to be the same. Right? And they also by T180 have to add up to be 120, because that angle is 60. So therefore, both of these angles are also 60. Oops. So what I have basically is a hexagon gets cut up into equilateral triangles, which is easier because I can use those later. Right? So now what I want to do is I want to find the area of one of those equilateral triangles. Right? So I'm going to kind of focus in on this one triangle here, and I'm going to find its area. Right? Now all these other triangles are the same, so I'm going to, whatever the area of this one triangle is, to multiply by 6, give me the area of the hexagon. Right? So in order to get the area of any triangle, I need the base and height. So I got the base, 12, and I'm going to drop the altitude to get the height. Right? So here comes the altitude. And that cuts, because it's isosceles, it's actually equilateral, but it cuts the base in half. So really what I have is 6 and 6. Right? And I got a little 30, 60, 90 action going on. Right? Side across from 30, that angle's half is 60, 30, 6. So that makes this 12, twice that, and my altitude is 6 root 3, my x root 3 side. 6 root 3. Okay, so that's cool, right? Because now I can find the area of this one triangle. 1/2 base, the base is 12, times height, 6 root 3. And then to get the area of the whole hexagon, I multiply that by 6, because there are 6 of these congruent triangles. So therefore the area of my hexagon is 6 of those 1/2 base, which is 12, times heights, which are 6 root 3. And a little magic, 6 times 1/2, let's see, that's 3 times 12, that's 36. 36 times 6, let's see, 36 times 6, what's that, 216? So I get 216 times root 3 square units. Right? Okay, notice this piece right here without the 6 in front, so kind of ignore that 6. But the rest of it is just the area of this one at really any one of those 6 congruent triangles. 1/2 base 12 times height, 6 root 3. Okay. How about a regular pentagon? Well, we can kind of do it in the same way, but this time we're going to start with the sides, let's say, being 10. So let's say all those, let's say all the sides are 10. Right, so that's 10. I'll put a little 10 out here, and all the other 5 sides are also 10. Not the arc, the side. So I just drew a circle around it just to kind of let you know we could think of these as being inscribed, if it's helpful. 10, 10, 10, 10, 10, 10, 10, right? So what I'm going to do is I'm going to cut up. I'm going to use triangles, right? So to find the area of that pentagon, I'm going to use triangles. I'm going to cut up into 5 congruent triangles using the center of the circle, or the center of the regular pentagon. Oops, that's not what I want to do. I want to go here, bam. And now I'm going to try to find the area of any one of these 5 congruent triangles, multiply by 5 to get the area of the pentagon. Okay. So I first want to start out with my angle, my central angle. There are 1, 2, 3, 4, 5 of them. All of them add up to be 360. So any one of them is 360 divided by 5, which is 72. Okay. So all these triangles, 72 degrees, 72 degrees, 72 degrees, 72, 72, they're all the same. And 10, the base 10, 10, 10, 10, etc., etc. Okay. So I want to find the area of any one of those 5 congruent triangles. So in order to do so, I have the base 10. I got to find the height. So I'm going to drop the altitude. And because those triangles are isosceles, it's going to cut the base in half. So really what I have is 5 and 5. Here and here. We'll call that a 5. And of course the other half is 5. I don't need to write that. And it also cuts the angle in half, so that makes that 36 degrees. Of course, if that's 36, this is 90. Then I can find that angle if I so choose. 36 and 90 is 126, which makes that by T180, 54 degrees. Okay. So I just want to find the area of this, any one of these 5 congruent triangles. Here's one of them. So the area of these triangles will be 1/2 base, which is 10 times height. So I got to find the height. So to find the height, I got to use trig, right? So what the heck is the height? Now the height also in this case is the apothem, the distance from the center of the circle to the chord. But if I use 54 as my reference angle, this is the opposite side, and 5 is my adjacent, so I'm going to use tangent. So if I call that x, I'm looking for this side, x, whoops. Looking for this height here, x. I'm going to use a tangent. So tangent of 54 degrees is equal to the ratio of the side I'm looking for, opposite over the adjacent, which is 5. Right? Multiply both sides by 5, whoop, 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 and we get the altitude of any one of those 5 congruent triangles, which is also the apothem, distance from the center of the circle to the chord. And I don't know what that is, but I'm going to use my calculator. 5 tangent 54. Let's see, 5 tangent 54. And bada bing, bada boom. Oops, that's the exact form. I want the approximate. So I'm getting 6.882. We'll call it 6.882. So that height is about 6.882. Right, which is this piece right here. Okay, so now I therefore can find the area of this triangle. I got the base 10, I got the height 6.882, and therefore to get the area of the pentagon, multiply that by 5. All right, so area is 5 of those 1/2 triangles, base, which is 10, times height, which is 6. oops, 882. Again, if I kind of ignore the 5, that is just the area of any one of those 5 congruent triangles. But I have 5 of them that make up the pentagon, so I need to multiply that by 5. Okay, now I'll turn to my handy-dandy calculator. Basically, I want 25 times what I just got. So I'm going to multiply that by 25. And that's going to tell me 172.048. 172.048 square units. Untees or units. Okay. So again, the idea, guys, is just cut up into triangles, find the area of one of them, and then multiply by the number of triangles that make up that regular polygon. Okay. Hope you enjoyed this. Bye-bye.